Hello everyone. Now the topic is about mass moment of mass moment inertia of cylinder. Moment of inertia at the parallel axis theorem. A point mass m at a distance r from the axis of rotation. A point mass does not have a moment of inertia around its own axis, but using the parallel axis theorem, a moment of inertia of around a distance axis of rotation is achieved. This is how the parallel axis theorem achieves a rotation. I is equals to mr square. Mass moment of inertia of cylinder. Thin cylindrical shell with open ends of radius r and mass m. This expression assumes that the shell thickness is negligible. It is a special case of the thick-walled cylindrical tube for R1 is equals to R2. Also, a point mass m at the end of a rod of length r has this same moment of inertia, and the value r is called the radius of gyration. I is equals to mr square. This is how the inertia of value r called the radius of gyration. List of moment of inertia. Moment of inertia denoted by the I measures the extent to which an object resists the rotational acceleration about a particular axis and is the rotational analog to mass m, which determines an object's resistance to linear acceleration. Mass moments of inertia have units of dimension, mass, length, which should not be confused with the second moment of inertia, which is used in beam calculations. The mass moment of inertia is often also known as the rotational inertia and sometimes such as angular mass. For simple objects with geometric symmetry, one can often determine the moment of inertia is an exact closed form expression. Typically, this occurs when the mass density is constant, but in some cases the density can vary throughout the object as well. In general, it may not be straightforward to symbolically express the moment of inertia of shapes with more complicated mass distributions and lacking symmetry. When calculating moments of inertia, it is useful to remember that it is an additive function and exploit the parallel axis and perpendicular axis theorem. The article mainly considers symmetric mass distributions with constant density throughout the object, and the axis of rotation is taken to be through the center of mass unless otherwise specified. Mass moment of inertia of cylinder. These are the formulas of mass moment of inertia of cylinder. Mass moment of inertia about x-axis, Ix is equals to m by 12 into 3r square plus h square. Mass moment of inertia about y-axis, Iy is equals to m by 12 into 3r square plus h square. Mass moment of inertia of z-axis, Iz is equals to m square by 2. This is the mass moment of inertia of some simple homogeneous bodies. Determine the moment of inertia and radius of gyration of homogeneous right circular cylinder of mass m and radius r about its circular central axis. K is equals to root over z by m is equals to root over 2 pi 2 r. This is the expression of mass moment of inertia. Mass moment of inertia formulas in rectangle Ix is equals to bh cube by 12 h by root 12. Ix is equals in triangle Ix is equals to bh cube by 36 h by root 18. Whereas in circle pi r square 4 or pi d power 4 by 64 r by 2. Moment of inertia of a rigid hoop. Find the moment of inertia of the hoop of mass m and radius r about the z-axis. In this case, the radius is fixed of the for the all mass elements. Iz is equals to integral r square dm is equals to r square integral dm is equals to mr square. NB, this is also the moment of inertia of cylindrical tube of length L and wall thickness. Thanks for listening.